Hi, what's up? Mr Haiwei here. Today I'm inspired to shoot this video because we've just finished the end of year exams and I have a bunch of Sec 3 students who didn't do so well, okay? There's this recurring problem that I see after an entire of very intense learning of 2/3 of the Sec 3 A-Maths syllabus. They find it very difficult that by the end of year exams to actually cramp it all in the brain and then bring it to the exam hall. Okay, you can practice and practice, but some things you just find it so difficult to remember. And so I thought to myself, what can I do? Of course, I have all this knowledge in my head, and what I'm going to do is I'm going to write out from memory all the stuff that I remember about all the topics. So what you're going to do is you can try to do the same thing and then perhaps try to replicate this set of notes that I have inside my head and see if it can make sense to you. Right? So I don't know how this is going to work out. Leave your comments below and share with me what you think of this, okay? Or what else can I do to help you? Alright, so our first topic in A-Maths is simultaneous equations, and really there is nothing much to talk about, okay? Substitution method, make sure it's correct, be careful. Very easy to make careless mistakes, but nothing much to talk about. So we're going to skip right to polynomials, and the first concept we have here is long division. Alright, so we have this example here, and we're going to do a long division. Now there are 4 terms here that I think many students are pretty confused about, and that's divisor, dividend, quotient and remainder. Now before we do this, right, maybe it could be quite hard for you to even kind of put all this in place, but you will do a division sum that is very, very familiar to yourself, and I typically use 13 divided by 4. So we do this long division. 4 times 3 is 12. 13 minus 12 is 1. Okay, so at the end of this we say that, okay, there's 2 ways you can say it. We can say that 13 divided by 4 gives us a quotient of 3, and then there's a remainder of 1, right? And well, divided by, okay, I can put this as a plus. So 3 plus 1 over 4. So this is the quotient, this is the remainder, this is the divisor, okay? So this is the dividend. The dividend is what you take to divide. The divisor is the number that you divide by. This is the quotient, the result of the division. And this, no, not this one, this is the remainder. Okay, or the other way is we cross multiply this. We can also say that 13 is equals to 3 times 4 plus 1, okay? So as I said, I use 13 divided by 4 as a very simple example to illustrate how long division works, okay? And you can do this also in the middle of the exam if all of a sudden you feel very panicky, you don't really know what you're doing anymore, okay? 13 divided by 4 is going to help you. Okay, so let's look at this one. We're going to do x over 3. We're going to do x cubed minus 1 divided by x squared minus 2. Okay, so we have, I'll just write it out in the long division form, x cubed minus 1 divided by x squared minus 2. So what you do is you multiply such that the first term that you get will be x cubed. So x squared times x is x cubed. But then the negative 2 also multiply by the x and you have minus 2x. Okay, now be careful here because when you have minus, it's applicable to both. So I will always write minus. Some students like to write minus and then cover this. No good. I have minus and then there's a bracket here to remind myself that this minus sign is applicable to both terms. And I'll always do this. Okay, mentally I'll do this. X cubed minus x cubed is 0. Nothing minus negative 2x is positive 2x. And then you have minus 1 here. Okay, so we are done because this power of x is lesser than x squared, so we are done here. So now we make a comparison. We see that this is the dividend, this is the divisor, this is the quotient, and this is the remainder. So likewise, this is the dividend, the divisor, the quotient, and the remainder. And we can say that, okay, we put it this way. We say that the division of x cubed minus 1 over x squared minus 2 is equals to the quotient, which is x, plus the remainder divided by divisor. Okay, so that's one way to write. And the other way is we can cross multiply this, and we have x cubed minus 1 is equals to x times x squared minus 2. Now if you notice, I cross multiply this way, this one gets cancelled off, and I'll have plus 2x minus 1. So that brings us to this equation here that is used only in the more advanced questions. And we say that this is the divisor, right? No, this is the dividend. We say that the dividend is equals to quotient times divisor plus remainder. We use this form typically for polynomial questions, and we use this form. Okay, if you write it this way, you will see that, which is this form, right? We use it for partial fractions. Yeah, we can continue with partial fractions with this particular term. Okay, yeah, that's about it. So remember this equation here. It could be a bit difficult to remember, but if you write out, lay out, right? Your 13 divided by 4, you will see that this divisor, this dividend, this quotient, this remainder. Okay, and this one you have to remember, and you will be able to pull this out in the middle of the exam if suddenly you can't remember. Okay, you pull it out and then you try to make sense, orientate yourself, and then carry on, apply it to the question. Alright, I cleaned out the board and I parked everything for long division on this side. Next, we talk about remainder and factor theorem. The remainder of any polynomial divided by a linear factor x minus a. Okay, you don't have to do long division to find out. All you need to do is let x minus a equals to 0, and then you sub the a into the fx. Okay, and we say that this is f of a. So okay, you can see that the x is replaced by the a, you sub a into the x. Every x that you see in the polynomial, you sub it in, and that result there in numbers is going to be the remainder. However, if x minus a is a factor of fx, then we take fx divided by a factor, there is going to be 0 remainder. Okay, then that means f of a is going to be 0. Well, that's about it for remainder factor theorem. Nothing much else to say. Alright, the third thing I want to talk about is cubes. And in polynomial questions, sometimes you will get this a cubed plus b cubed, which is called the sum of cubes. And you have a cubed minus b cubed, the difference of cubes. There is an identity here that we can use quite easily to do this. And it is actually, I find it very difficult to memorize. I don't know why. Until it's only this year that I began to memorize it. Okay, but it works now. I can do it. A cubed plus b cubed is a plus b, bracket, okay, plus you have a plus, okay, and then you have a squared, b squared, right? Now this part here looks like a quadratic identity, but it's not, because in the middle it's not 2ab, but it's just ab, right? And if it's a plus, then this is a minus, but this is also a plus. Okay, so we focus on this sign and this sign. If this is a plus, this is a minus, and if this is a minus, this is minus. And a squared is going to have a plus ab plus b squared. Yeah, so that's the memorization part of it. The reason why I didn't memorize it for so many years is because I always have a workaround, okay, which I pull out in the exams. And whenever the question comes, I cannot remember, I'm just going to do that. And that is to use binomial expansion to get this identity. Okay, I can completely get this on the spot by using binomial expansion. If you haven't done binomial expansion, please learn it and then come back and watch again next time. But if you learn already, then this is going to be helpful. Now, if I want a cubed plus b cubed, I'll start off with a plus b, bracket cube, and I'm going to expand it using binomial expansion. Okay. Now, you're thinking it's going to take a long time. No, actually it's very fast. Because this is a cubic expansion, we know that there are 4 terms. The powers of a are going to start from 3 and then reduce by 1 each time, right? the powers of b is going to start from 0 and then increase each time until you get b cubed. And the other thing I know is that the coefficient of expansion is 1, 3, 3, 1. So with all that, when you put them together, I have a cubed plus, okay, this is a squared here, but the coefficient is 3. Then you have a squared, b 0, b 1. So you have b here, plus, coefficient is 3 again, a squared here, so you have a, b here, you have b squared, the power increases for b, decreases for a. And the last one is b cubed. Right, so what we want is a cubed and b cubed. So everything else, this one and this one, I'm going to move it to the other side. So you have a plus b bracket cube minus, okay, I'm going to at the same time factorize this. You guys are A-math students, you can handle it. When it goes over, it becomes minus, but at the same time, 3ab are common factors. Is a common factor, okay? So 3ab bracket, you have another a here, you have another b here. Yep. So this is equals to a cubed plus b cubed. Okay, so we're going to swap this. A cubed plus b cubed is equals to, you can see that you have these two terms here, right? Okay, this is the first term, this is the second term, and a plus b is a common factor. So I'll factor out a plus b. And I have a plus b bracket squared. Because from a plus b cubed, I factor out a plus b. So if I multiply back in, right, I'll get, so from a plus b cubed, if I factor out a plus b, I get a plus b bracket squared. Okay, and if I actually multiply them back, I'll get this again. So that makes sense. And this one, if I factor out a plus b, I get minus 3ab. If you expand this and then we simplify, you know that a plus b bracket squared, there's a plus 2ab inside. Plus 2ab minus 3ab is negative ab. So you have the expansion, you have a squared, right? And then you have b squared. Plus 2ab minus 3ab is minus ab. Which is exactly what we have here, right? Alright. I would like you to try to get the other one, but at this point students will protest, okay? So fine. I'll do it for you. A minus b bracket cube. It's exactly the same as this, except now the terms are going to be alternating between positive and negative. The first one is going to be positive, the second one is negative. Okay, because you multiply by b to the power of negative 1. And then it's negative. But this one will be positive again because the b is squared. So the negative gets squared off, becomes positive. And you have minus b cubed. Okay, so same thing, we keep the a cubed minus b cubed and we move these two terms across. A minus b bracket cubed. This is minus, right? Becomes plus. This minus go over become plus. This plus can become minus. Okay, so this is 3ab again is common factor. This go over become plus, so that you have a here, but then this is minus b. Okay, so this is equals to a cubed minus b cubed. So a cubed minus b cubed is equals to this one. We do the factorization again, but now the common factor is a minus b. And okay, you go and figure it out slowly. Okay, it's a squared plus ab plus b squared. And we have this result. Okay, so if you can memorize, if you can't, at least you have to have in your pocket already a workaround, which is binomial expansion. That's an alternative to do it. Okay, for years I've done this and I could get away with it. But please, you know, for the sake of the exam, please memorize this. It's better. Okay. Why not be able to do both? That'll be even better. Finally, we have partial fractions. It's a favorite among Sec 3s because it seems so easy to do, but when it comes down to the questions, students will always forget their case 1, 2, 3, and 4. Okay, so we are going to do exactly that. I'm going to help you remember your case 1, 2, 3, and 4. However, I'm not going to organize it in the same way as the way you see in the textbook, like case 1 linear, case 2 repeated linear, case 3 quadratic that cannot be factorized, case 4 you have improper fractions. Okay, the textbook organized it that way because you learn it in that order, from the easiest to the most difficult. But when you look at the question in the exam, the first thing you have to look at is whether the partial fraction is a proper or improper fraction. Okay, so we'll check the first thing whether it's an improper fraction. When you go to the question. So, is it an improper fraction? You ask this question, okay? If the answer is yes, then you do long division. Okay, but if it is no, then you consider your case 1, case 2 and case 3, okay? So, then we have your case 1, case 2 and case 3. So we always observe the denominators. Okay, this is case 1, 2, 3. Your denominators, if you have say x plus 2 over x plus 1, x minus 3, you know, just a random example. Okay, then this is what we call linear. Okay. And we have the next case is repeated linear. I think it helps to remember these names. And then you have a quadratic that cannot be factorized. Yeah, I don't see how you can work around this. If you don't remember the names, how are you supposed to remember the concepts? I always think names are important because names give you an idea of certain things. The name also helps you because it's kind of like a description of the term that you see there, right, in the partial fraction. So it's important to remember the names. Okay, when you have names, it's easier to remember. Repeated linear is like when you have say x plus 2. Okay, I'm going to just mostly use this one. But your x minus 3, right? I'm just going to write it in a different color. X minus 3 bracket squared. So this one is going to give us two terms. Okay, a over x minus 3, b over x minus 3 bracket squared. Then the third one is going to be say you have x plus 2 again over x plus 1 x squared plus 1. So this is a quadratic expression that you can't factorize. So that's what literally it is. Quadratic that cannot be factorized. Okay. So for linear, okay, I'm going to use this base here. So this one is going to give us a over x plus 1 plus b over x minus 3. This one, okay, there's this linear by itself. So that's going to get an a over x plus 1 plus this one, as I said just now, you get two terms, b over x plus 3 plus c over x minus 3 bracket squared. Okay. Finally, we have this quadratic that cannot be factorized. This x plus 1 is going to give us this a over x plus 1 plus this one is going to be by itself, but it's going to be, remember, the numerator power is always 1 less than the denominator. Okay, so this is a square here, x squared. In your numerator, you're going to have x. You're going to have linear in the numerator, so that means this is bx plus c over x squared plus 1. Yeah, and then you carry on and do your partial fractions. Right? Alright, so that's basically it. The 4 areas that you need to memorize for polynomials, partial fractions. Let me know what you think. Is this helpful? Okay, you can watch this before you go into the exam. Hear my soothing voice and feel a little bit more comforted when you go to the exam. Okay. yeah, that's basically it. Okay, like and subscribe. See you next time. Bye.